Hi everyone. So we have just learned about the first danger of concurrency, which was race conditions, isn't it? Now I'm going to introduce you to something else, which is the second danger of it. But for that, I'll pose you a question. So first, let's listen to the question clearly. I want you to write a concurrent program in which there are some threads. Let's say there are 5 threads. Now each of these threads is assigned a unique number in between 1 to 5. So let's say first thread is assigned 3, the next thread is assigned 2, the next thread is assigned 5, then 1, then 4. Now I want to launch all these threads from my main program, and I want to ensure that the values are being printed in a strictly sorted manner. So I want 1, 2, 3, 4, 5 to be my output. Okay. Now, how do I do that? So this is something that will require you to synchronize these threads in certain manner, because we all know that CPU schedules them randomly. Okay, so can you just pause the video and think how to achieve this thing? Let's do that. Okay, so there can be multiple ways to do this. Some ways are better, some ways are not so better. Some ways are working for certain scenarios, and for other scenarios they might fail depending upon a lot of things. I mean, they can be non-deterministic in their behavior. So we'll see all that, but let me give you the most basic solution that comes to the mind. So it's like a hint. Consider it like a hint, and if you want, you can pause the video after that, and then you can think on top of that again. Okay, you can basically try writing the program on your own before seeing my program. So guys, let's see, there are 5 threads and they have been assigned numbers like 5, 1, 3, 2, and 4. Okay, now you launch all these threads. What if your CPU scheduler first schedules the thread which has value 4 associated with it? Will you want that thread to print? The answer is no. So what would you want? You would want that thread to probably wait, if you know how to make a thread wait. And if you don't know how to make a thread wait, you can probably make it engage in certain other activity. Maybe by continuously running a while loop. And in that process, maybe a context switch can happen, and that switch happens to the thread which was actually supposed to print 1, and now that will print 1 and then move on, and then some other thread will be scheduled. So basically what I'm trying to say is that whenever a thread is scheduled whose value attached is not the value that we want to be printed, then we need to have a way in which that thread can be made to either wait or do something else, but not do the printing business. So can we ensure this in some manner? Just pause the video and think again. Okay, I'll tell you how I have ensured this. So you can see that I have a main class where there is a public static variable current, which is 1. And because this is public static, so this is global and this is shared. So that is the first thing which I want you guys to realize. I'm going to use a shared variable. So yes, if you are thinking that race conditions can happen, you are not wrong. Keep thinking about that. But let me talk to more important things. So you can see that I have created 10 threads and I have assigned them a unique value 1, 2, 3, 4, 5, 6 till 10. Okay, it does not matter what value I assign to them. I could have assigned 2 here, then 5 here, then 9 here. It's up to me, because I know that anyways the threads are going to be scheduled randomly. Okay, now you can see that I have started all these threads, and every thread has its own worker, which is nothing but a class implementing runnable interface. And you can see that it takes a value which I pass into the constructor. Now this is the most beautiful run method. This is where the entire magic is going to happen. Okay, now you can see that I had a shared variable current, and this current was initialized to 1. Okay, so there is a current which is shared across all the threads, and every thread has its own local variable called as val, which is basically the value that it is supposed to print. Now my logic will go something like this. Whenever a thread gets scheduled, I'll compare the thread's value with current. And if I'll see that the value of the thread, like here I can see 3, is greater than current, it will give me a clear-cut idea that, hey, this is not the time for this current thread to do its printing job. Now, I would want that thread to indulge in some other activity. So for that, what I have done is, I have written a while loop like this. Can you try understanding this while loop on your own by pausing the video for some moments? Okay, you can clearly see that if a thread whose value is 3 gets scheduled, it will see that 3 is greater than 1. And as long as 3 is greater than 1, it will keep on looping. It will keep on looping. And then a context switch will happen. Some other thread will get scheduled. Let's say the value attached is 5. That will also keep on looping because the current is still 1. Only when the thread 1 gets scheduled, whose value attached was 1, then that thread will be able to come out of this while loop and will be able to print the value 1. When it prints 1, it also increments the value of current by 1 unit. Now the current would become 2. When current becomes 2, again you can apply the same logic that I gave you to convince yourself that only when thread 2 is scheduled, it will come out of this loop, do the printing job, and increment the current to its next value, which is 3. So guys, this is just, I would say a little slightly intelligent technique in which I am synchronizing the printing process of the thread. Okay, and in order to do that, I have had to use a global variable called as current. Okay, cool. We are doing current plus plus. So do you feel that race conditions can happen over here? Just pause and think. So if you made out that, hey, race condition will never happen here, then you are not entirely wrong. See, other thread will only be able to move down this while loop when it sees that current has changed. Let's say current is initially 1, and when thread 1 is trying to update this current by doing fetch, update, and write, until unless it has finished its write, the other thread, which is thread 2, will never be able to come down and perform the change. So to us, on the first glance, it looks like that multiple threads are never going to interleave their fetch, update, and write. And because of that, it is thread safe. Okay, good. So race conditions are not going to happen. And we are going to take care of the fact that values are being printed in a sorted manner. So I would expect that the program runs. But do you know, I ran this program several minutes ago, and this program is stuck after printing 1, 2, 3, 4, 5. It has printed till 5, and after that, it has not printed anything. It is stuck. If I rerun this program, then maybe it'll go ahead and print everything. But maybe if I run it over and over again, it would give me some other output. Like this time you can see it has successfully printed everything from 1 to 10. If I run it again, it printed 1, 2, and now it is stuck. So something is wrong. Something very, very bad, which is making my program stay stuck. Okay. So you can now just think about what possibly could be wrong here. You can do your own debugging exercises also by putting some print statements with threads. You can attach a particular name to each thread, and then you can put some print statements to see that whether they are able to see the updated value of current or not. And you can just try to guess what possibly could have gone wrong. So do that. And in the next lecture, I'll explain you that what is this all about. This is very, very important thing. And this is the second danger of using concurrent programs.